Hello everyone. Today what we're going to take a look at is we're going to take a look at Hyper-V and Docker on Windows Server. We're going to create a Hyper-V virtual machine. We're going to use a dynamic disk to do that. We're going to use a bit of Windows Admin Center as well to actually do the administration. Then what we're going to do is we're going to install Docker via PowerShell onto a Windows Server operating system, and then we're going to run Nano Server on top of that as a Docker container. This is actually running Docker inside the context of Windows without having to install WSL to actually get this working. So we're going to use exclusively Windows containers here, and we're going to use Hyper-V to actually get those containers to actually run and execute. So stick around and let's get straight into the demo. Okay then guys, let's get straight into it. So I have here three servers. I have a server called ADM1. This server is going to be an admin server. It's going to have all my remote admin tools that I'm going to play with. We also have a server called SVR1, and this is going to be our Hyper-V server. This already has Hyper-V pre-installed on it, but we're going to create some virtual networks, we're going to create some virtual machines, and we're going to add some Docker support onto our Windows Server. We've also got DC1 over here as well, and this is just going to act as an AD domain controller for this lab environment. Let's just double check on what machine we are actually on at the moment. So if I just throw up PowerShell, type in a host name, and we should see I'm on SEA ADM1. Okay, that's cool. So let's just go pop up Server Manager over here. We're going to go and walk through a little bit of Hyper-V administration. So in here, we're going to go and select inside this all servers list. We should be able to see there's my three servers. There are a couple of other servers that are offline inside this lab environment, so we're not going to be using them. But we have this SEA SVR1. Now what we can do is we can right click on this and we can click on to Hyper-V Manager, and this is actually going to launch the Hyper-V MMC console, and it's going to launch it nicely remotely connected here to SEA SVR1. You can see we've also got on here a single virtual machine already running called SEA Core 1. Its state is off, so when I say it's running, it's not running, it's there, it's created. So what we're going to do first of all is we're going to drop into Virtual Switch Manager. And in this Virtual Switch Manager, we have an existing private network. Remember, we have three different types here of networks. We have an external network. This will connect to our network adapter, and it will allow our internal Hyper-V machines to actually act as if they are physical machines on the network. They can get IP addresses from DHCP servers, all sorts of wonderful things. We have an internal network. What this is, it's basically a NAT network. And what happens is we've got this internal switch running with some network address translation to get out to the outside world. So our virtual machines don't have IP addresses that are on our network. They have IP addresses that are isolated inside their own network, and they have this kind of gateway out. And then we've got private network, which is what we're going to use at the moment, which is just a completely isolated network. So the virtual machines can only talk to each other. They can't talk to anything else. So we're going to go for private for the moment, and we're just going to create a new one over here, a new private network. That's fine. Create that virtual switch, and we're going to call this the Contoso private switch, just because that's the name of the network we're working on at the moment, and we're just going to apply that. So we can have a lot of private networks if we want to. They're all nicely isolated from each other. So on here, what we want to do now is we want to go and create a new virtual hard disk. Okay, so we're going to go to new, and we're going to go to virtual hard disk, or hard disk over here. And we're going to choose the VHD format. There is actually three different format sizes here. VHD is kind of the old format, but it'll work for this demo. VHDX is the newer format, and this goes up to 64 terabytes in size. And we've also got this thing for VHD set, which is for shared virtual hard disks only, and a little bit more advanced than what I want to show off in this demo. So we're going to choose the most basic here, which is just virtual hard drive, only up to a max of 2 terabytes in size. And we're going to choose a differencing disk. The reason why we're going to choose a differencing disk is because what we can do is we can actually attach this to a base image. Now the idea of that is, if you have a base virtual hard drive, this will actually have a copy of Windows installed on it. But it's going to be a copy of Windows that has no configuration on it. It's just the base copy of Windows. And then with our differencing disk, we are going to label this on top here, on differencing disk, and we're actually going to link these two together. Our virtual machine is actually going to connect to this differencing disk, and any changes, any data that virtual machine creates gets attached here into the differencing disk, not into the original source disk. This original source disk down here is actually going to be read only. But what that means is we can actually create multiple differencing disks if we really want to. We can have another differencing disk over here, actually attach that same source and have another virtual machine attached to that differencing disk here. So we can go kind of reuse that base disk if we want to. So let's go create a differencing disk at the moment, and what we want to do is on this specified name and location, we're going to call this SCA VM1, and the location of it we're going to change down to this location of C base just to keep it nice and simple. I'm going to go into this, and it's going to ask where the virtual hard disk is for the parent image. We do have a base image here, and it's called baseimage.vhd. This is going to contain a copy of Windows Server that we can use, and it's going to be linked through that differencing disk. So let's go next on that one, and let's go finish on that one. So now we've actually built the disk, we can now go and create the virtual machine. Now, if you've been through this process before, you might be aware that if you do go through the process to build a virtual machine, you are going to get a virtual disk attached as well. But you can't do the differencing disk thing actually within this virtual machine wizard. So to do the differencing disk and attach to a source drive, you have to go and create the virtual hard drive as I just did. So let's go through here. We're going to call this SCA VM1. We're going to store this virtual machine in a different location. We're going to store this in C base. That's fine. And we're going to use a generation 1 virtual machine here. The main difference between generation 1 and generation 2 is this thing is essentially virtual BIOS, and this thing is essentially virtual UEFI. So if you're using really modern operating systems, like for example Windows 11, you are going to need to use generation 2. At the moment though, I'm using an older copy of Windows Server. We'll just use generation 1. It'll be perfectly fine for what we want to do. Also, generation 1 gives us access to things like virtual IDE and virtual floppy drives, which might sound quite old, but virtual floppy drives do still have a couple of useful things to do inside a modern environment. So we're going to connect that to Contoso private switch over here, the one that we created before, and on the connector virtual hard drive, we're not going to use this. This is going to try and create a new virtual hard drive. We're going to use the existing virtual hard drive that we actually just built. So let's go and browse now into SCA SVR1, and let's go and browse into the base. Notice I'm browsing on SCA SVR1. Notice I'm completely remote connected to SCA SVR1, but I am actually still on SCA ADM1. So this is all remote admin stuff. You could do this from your client computer if you wanted to as well. So we're going to go and grab that disk that we created earlier, that SCA VM1 VHD, and we're going to open that thing, and we're going to hit finish on that one. Okay, that's cool. So what we can actually do is we can still adjust settings afterwards. So if we drop into the settings of SCA VM1, and we can see down here we've got things like our hard drive is connected to the virtual IDE controller. If this was a generation 2 virtual machine, this would actually all be virtual SCSI. But what we can also do is we could come into here, and we could, for example, do things like enabling dynamic memory. We can change that maximum RAM around to 4 gig. So this is actually just going to dynamically expand and contract the amount of memory assigned to this virtual machine dependent on the load of the memory itself. It makes a much more efficient use of the RAM on your physical servers that are running Hyper-V. Alright, cool. So what we can also do is we don't technically have to just use this Hyper-V manager over here. We could manage this in a multitude of different ways. We could go into Hyper-V over here, and we could see we've got specific events, so we could actually see the Hyper-V services. We can't do much here through Server Manager. We could, if we really wanted to, do something like enter-ps session, dash computer name, SEA-SVR1. We can remote admin to this, and we could do something like get-VM, and we could see the running virtual machines running on here because our Hyper-V module for PowerShell is installed, so we could remote administer that way if we really wanted to. Or what we could also use is we could use something like the Windows Admin Center. So the Windows Admin Center is a separate download. Let's go and connect to this. This is currently running on this server at the moment. So what I need to do is I need to just go and log into this thing. So let's go and log into this with Contoso Administrator and my appropriate password. Whoops. There we go. So Windows Admin Center is loading, making me panic there. That's not actually running. So we have our SCA ADM1 already connected here because this is where Windows Admin Center is actually running. If you want to get Windows Admin Center yourself, just go to Windows Admin Center, download, grab this thing from here. You do a next install, and then Windows Admin Center actually installs on the computer you're running on, and it gives you this web interface to actually connect to. The Windows Admin Center, in summary, is doing the same job as Server Manager, but it's actually good because Server Manager, well, to be on a Server Manager kind of site. So on here, we're going to go and add on our connectors page, and we're going to go and add another server, and we're just going to go and drop in that SCA SVR1 server here. Give it a second. It wants some credentials for this, which is fine. We'll give it these credentials to actually go and connect, these same Contoso administrator credentials, and we're just going to go and add that with specific credentials. We'll give this a second, and we've hopefully nicely added it there. So what we can do now is we can go into SCA SVR1 over here. So what we can do here on SCA SVR1 is we can scroll down here, and we can go into virtual machines. So we can kind of control our Hyper-V environment here from within Windows Admin Center if we want. So everything that you can do kind of in this section over here, you can kind of do over here as well in a slightly different way. Technically, this is kind of sending PowerShell commands into the system, but it's a much nicer way of playing with things. So down here, we can select our SCA VM1, the one that we just created, and here's all the properties for it. There's no memory assigned to it, there's no replications, there's nothing happening because it's not turned on at the moment. But what we can also do within this virtual machine itself, we should be able to go to the settings of this virtual machine, and we should be able to go into disks, and we can actually go and add extra disks here if we really want to. So we've got one disk already added in here, this SCA VM1 VHD. We can go and add this in here. We can actually go and create a new virtual hard disk if we really want from this interface. So inside this new virtual hard disk, it's going to be called in CBase. So we're going to change the size down to 5 down here. And we're just going to leave this as the same default name, SCA VM1-1, but it is a secondary hard drive in here as well. Let's go and create that. We've now got 2 disks actually attached to this virtual machine. One that we created in the old format, in the old MMC console, and another one here created in this Windows Admin Center. Right, let's go start it up then. So back into the virtual machines itself and back into SEA VM1. Where did you go? There we go. Let's go into power over here and let's go and start this thing up. All right, cool. So it might take a minute to start. These are not the fastest servers in the world. We can also see down here, it's actually starting here as well. Oh, it's actually running. That's nice. We can also turn it off from here if we really wanted to, but we can also see the statistics for this thing running. So if we go into, whoops, here, oh, we haven't got any statistics just yet. Let's just go and refresh this. I could click off it and click on it again, I suppose. That'd be one way of refreshing it. And we should be able to see, there we go, there's some statistics. We've got 4 GB of assigned RAM, it's using 6% of CPU, it's up and running, that's good. And underneath the properties, now we should be able to see, oh, wait for it to load. There we go, we can see it's running Windows Server 2019 Data Center Evaluation. The computer name is called SCA Core 1, it's got that name from the original disk. That original base disk and dynamic memory is enabled. So that's all cool. Right. So what we can also do down here is we could go through and we could start to actually install containers into our environment as well. Okay, so we are currently remote connected here to SCA SVR1. Maybe we don't want to run virtual machines here. Maybe we want to actually run some Docker containers. Now, that would be great. So to do that, what we're going to need to do is actually get Docker installed. Now, Docker normally runs on Linux machines. It does run on Windows, and there is Windows containers as well. They're normally just used for isolating things like IIS instances. If we go into PowerShell here, or remote PowerShell on SCA SVR1, we're going to need to run a couple of commands just to kind of get Docker installed. This first little command here is actually going to force the use of TLS 1.2, and it's actually going to go and install a correct PowerShell Git module. This is just going to make sure that everything's updated, so I can actually go and grab Docker in a moment. So let's just wait for this to install. Once this is done and PowerShell Git modules are actually completely updated, this is a bit like doing an apt-get update if you're ever in Linux land. I actually need to go and restart this computer. So I'm going to restart SEA SVR1, and we're going to come back to that in a minute. Okay, so now our server has actually rebooted. It's running Hyper-V. We're going to go and connect back to that with an enter PS session with SVR1. And now what we're going to do is we're going to install this Docker provider module from the PowerShell gallery. This is going to allow us to have links to be able to go and download and install the Docker version for Windows Server. Let's give this a moment to actually install. And now we're going to go and run this install package Docker from the provider, Docker provider. Wonderful. It's going to take a second to install, and once it has installed, it's going to need another reboot as well to be able to have Docker actually running on this Windows server, ready to rock. All right, cool. So we can see we've got Docker now actually installed, Docker for Windows Server 2016. This is 2019, but it's still perfectly fine. We just need to do yet another reboot over here now that Docker is actually installed, and we'll come back to this in a second once it is rebooted. Okay, so our reboot should have completed by now. Let's go back and, oh, don't want to do that. We want to get rid of that. We want to do an enter-ps session, computer name, and let's go connect to SVR1 in here. Whoops, not that. It would help if I put the name of the server incorrectly, wouldn't it? So let's go and connect to SEA SVR1. There we go, and we're all back. So now what we should be able to do is we should be able to verify that Docker is actually installed on this computer or on this server ready for us to use. So let's do a get package named Docker, Docker provider with the Docker provider source, and give this a second. It'll take a moment on the first run. There we go. So Docker is actually installed. If we type Docker in here, let's see what we've got. Just make sure we've got the Docker commands installed. Whoops. I read there. Mistyped that. Hang on, let's do the Docker commands there. All right, cool. So this is all coming up as a native command error. That's fun. So let's just do Docker images. Yep, that's actually working. And let's just do Docker PS and make sure that we have no Docker containers actually running at the moment. Okay, that's cool. So we're only getting this error of not specified because it's the Docker command trying to run in a PowerShell shell. It's actually just returning the default commands down here to tell us what we can actually do. So it's all coming up in red, but it's not really an error. It's more of a, here's the things you can do with this Docker command. So we're going to go and pull a server image down here. We're going to go and pull the Nano Server IIS image. Now, Nano Server originally used to actually be a full server product, and what you could do is you could install it into a virtual machine. And when you did, it was like a really, really, really tiny cut down version of Windows Server, and you could install various different plugins into it. One of those plugins being IIS. So it's kind of like just enough operating system to run the IIS server. Microsoft kind of gave up on that idea of it running as a virtual machine or even running on physical hardware, because you could run Nano Server originally on physical hardware to run things just like Hyper-V. But they kind of gave up on that, and now Nano Server is pretty much just used as a base image for Docker images. So in this case, it's just downloading this Nano Server IIS image. If we go and have a look at, for example, hub.docker.com, which is where this Docker command is inherently hooked into and is pulling the images from. If we go and have a look at Nano Server inside here, we'll just snooze that for a moment. We can see here are the Microsoft versions here. We've got Nano Server /IIS down here. It's actually quite old at the moment. It's 6 years old. As I said, this is possible to run these Nano Server base images and actually run Windows software containerized or Microsoft Server software containerized. But Microsoft now are really just providing the base images, so you can run your own code inside there if you want to. So let's go and have a look inside here. That pull is complete. That's good. That's good. Let's give it a second for the shell to catch up with itself. Remember, this is all taking place on SVR1. Also, to actually have Docker running on a Windows server, you do actually need Hyper-V installed because it relies on those Hyper-V components to kind of run the Docker engine. So let's go and check out Docker images, and we should have that Nano server IIS actually running. That's wonderful. And now we can actually go and Docker run it. So we do Docker run. We can use the isolation of Hyper-V. So what it's actually going to do is it's going to use the Hyper-V components to essentially take this container itself and isolate it with its own hardware, its own virtualized hardware. We've got -d, which is run this as a daemon, so we're going to run this container in the background. We've got -t, which is, can't remember what -t does. Give me a second. Docker run -t. -t does interactive mode. Okay, so we're actually going to be connecting to this as well. So it's going to be running in the background continuously, and we're putting -t in there to give us a terminal, to give us interactive connectivity to it as well. I'm going to call it Nano. The internal and external ports are both 8080, and we're just going to run this as Nano server IIS. So it's going to execute that, and we should hopefully have an IIS web server now running inside a container on a remote Windows server computer here. What that means is we can actually run multiple copies of this if we want to. So we can go and actually execute multiple IIS servers on the same server at the same time without having to create multiple different virtual machines and having all that overhead. Let's give this a second. Let's do Docker PS in my other shell. It's slowly coming up. It will take a second for the first image to come up, but once that first one is actually up and running, the future IIS servers will take just a fraction of a second just to kick in. So that's all nicely running now. So we can actually go and see with Docker PS that current thing actually running. We could also do something like Docker stats. And if we go and run Docker stats, we can also see our Nano container actually running for us down here as well. If we wanted to, we could create another one. So if I run that same command again, just change around the name a little bit from name to Nano 2. I'm also going to have to change the ports as well because we've got the same external port. So we've got port 80 and port 80. So I'm going to change that to port 81. I'm going to rerun this because we can't have multiple ports running on the same system at the same time. Whoopsie, I've done that the wrong way around. Sorry, that's the internal port. I need to change the external port to port 81. And I'll call this Nano 3 now because there's also a conflict on there. So that's very, very quick to actually spin up a new instance here. So let's just cancel that. Let's escape this, go back to Docker stats, and we should be able to see here. Whoops, don't let it come up. There we go, Nano 3 is actually now bounced up. So it took a lot less time to bounce that up. Let's do another one, let's do a Nano 4. And we'll change that to a port number of 82, and we'll go see how long that takes to come up. So just whacked enter on this and give it a minute, and it should come up quite quickly. If you've got more modern servers with much faster RAM and much faster CPU, this is kind of fractions of a second for it to come up. It's quite elastic. But even here, there we go, Nano 4. So these are each 3 completely separate, completely isolated systems on here. So my container host down here, if I go and run ipconfig, I should have an IP address here of 172.16.10.12, which is the IP address of my server, my SVR1 server. So if I want to go and connect to these IIS services, I can just bounce up Edge over here, and I could bounce in, for example, here. Whoops, don't want to do that twice. We should get IIS start page. There we go. This is the IIS start page that's actually connected to this default Nano over here, because this thing here was running on port 80 and I have not specified a port here. But if I go and specify, for example, port 81, which is linking to the other container, that is now connected to Nano 3, which we know is running on port 81. And if I go and change this to port 82, that's connecting to this one called Nano 4. So what I've actually got is I've got 3 separate isolated IIS containers all running on the same physical host at the same time. There are kind of additional configuration steps after this to maybe get these to point to specific websites or specific data that you want to host. but the concept is pretty straightforward here. And the fact that these are running not with Linux bases, but these are actually running with Windows Server bases and running on Hyper-V to do it. So if I go and run docker ps, we should be able to see, there we go, there's my 3 servers. These are the container IDs, the unique IDs for each of these. And if I wanted to actually go and stop one of these, I have to go and stop these things by its container ID. So let's go and take one of these container IDs up here, like this one, to go and stop Nano 4. Go and paste that in there, and that will kill that server. We should see Nano 4 should die off in a second. Let's go and rerun this. There we go, Nano 4 has died off. So if I want to go and stop the next one, let's go and stop Nano 3. I'd have to go and get its container ID over here and actually go and pop that in there. Whoops. Let's go and delete that. Sorry, I caught a little bit too much. There we go. We can go and stop that container as well. We can also use the admin center to go and look at some of this stuff as well. So if we go and pop back over here to our admin center, we could go into, where is it? Here we go, containers. So we've actually got a container option. Now we don't have a container option over here on our server manager. Server manager came out way before containerization actually started on Windows Server, so it's just not there. But we can actually see the containers that are currently running on our Windows Admin Center. We can actually go and see the current containers that are active, and we can go and manage them from here. So there's my Nano servers, the ones that we just exited, and there's the one that's actually currently up, which is the original one running on port 80. We can go and see the details and the logs. We can also even connect to the console of this, so we can go inside the container itself as if it's kind of like a virtual machine too. We can also see our existing images that are built on here, and our existing networks and volumes. So this is kind of being a replacement for the Docker desktop application, if you're used to that running on Windows. But here we can see it all nicely in a Windows Admin Center. So that kind of brings us to a bit of a conclusion, and what we've done is we've had a look at Hyper-V. We've looked at very quickly how to create a virtual machine on Hyper-V remotely by using the Windows Admin Center and by using the Hyper-V MC console. We've also looked at creating a dynamic disks here, and we've also looked at building and installing Docker into Windows Server and running Windows containers inside that server. And you know the routine, hashtag like and subscribe, and I hope you enjoyed this video and will join me next time. Goodbye.